Hi there. Going to work this problem out for you with this circle here. Uh, we have this is called an inscribed angle here, angle ADC, and the measure of this angle is 35 degrees. Well, and this is a central angle, angle AOC. And so the way it works here is there's a theorem in geometry that says the measure of a central angle, AOC rather, is going to be twice the measure of this inscribed angle, which is angle ADC. So therefore, angle AOC is going to be equal to 70 degrees, 2 times 35 degrees, or 70 degrees. So that is going to be the measure of angle AOC. So this is a 70-degree angle. And now, since we know that AO, this side of our triangle, is equal to side CO, both 9 centimeters, we have an isosceles triangle. And so therefore, if I drop a perpendicular from the vertex O down to side AC, this perpendicular will be a perpendicular bisector of AC. And so these lengths here have to be equivalent to each other. Okay, so this length here has to be equivalent to this length here. And to find those lengths, what we're going to do is I'm going to pull this triangle out of this circle here, and I'm going to put the triangle kind of like upright here so that we can better see it and work with it. And so therefore this is going to be the triangle AOC. So this is our 70-degree angle. And we got a perpendicular bisector here. So we have a right triangle here. So we got a right triangle here. And we know that this side here, the hypotenuse, has a length of 9 centimeters. And so if this is 70 degrees and the sum of the three interior angles of a triangle are 180 degrees, then it must be true then that 180 degrees minus 70 degrees divided by 2 must be equal to the angle of angle C and equal to angle A. So 180 minus 70 is 110. 110 degrees divided by 2 gives us a measure of 55 degrees for angles C and angle A. So both these angles must measure 55 degrees, these base angles of this isosceles triangle here, 55 degrees also here. So now we have a right triangle here, and therefore I can find the length of this side O. I'm going to call this OB here. So we can find the length of side OB by using a trig function. As far as my 55-degree angle is concerned, OB is opposite my 55-degree angle, and the 9 centimeter length is the hypotenuse. So I can set up this trig relationship. The sine of 55 degrees therefore must be the opposite side, which is OB divided by 9 centimeters, which implies that OB is going to be 9 times the sine of 55 degrees. Okay. So side OB is really the height of my triangle here. And the height of my triangle is therefore going to be 9 times the sine of 55 degrees. I can now find the length of side CB by using my 55-degree angle and using the cosine function. So therefore, cosine of 55 degrees is equal to the adjacent side, which is side CB, divided by the hypotenuse. So this would imply then that CB is equal to 9 times cosine 55 degrees. But the base CA has to be twice the length of CB, because remember, OB is a perpendicular bisector of CA. So therefore, the length of our base of our triangle here, CA, must be 2 times the length of CB. So it must be 2 times 9 times the cosine of 55 degrees, which is to say 18 times the cosine of 55 degrees. Now we can find the area of our triangle, which is 1/2 times the base times the height. So the area of this entire triangle would be 1/2 times its base times the height. So the base of this triangle is CA, which is 18 times the cosine of 55 degrees. Times the height of this triangle is 9 sine 55. And so therefore, the area of this triangle is going to be this here, and we can approximate it if you get on your calculator. Make sure your calculator is in degree mode here. If you take 1/2 of 18, which is 9, times the cosine of 55 degrees, times the sine of 55 degrees, and I'm getting the area of the triangle, which is about 4.23 square units. So that's the area of the triangle. But we want to find the area of this shaded region here. So to find the area of the shaded region, we're going to have to find the area of this whole sector. So what's the area of sector AOC? Well, the area of sector AOC is going to be 1/2 times the measure of the central angle, which is 70 degrees, but 70 degrees has to be converted into radians. So the area of this entire sector AOC here is going to be 1/2 times the measure of the central angle, 70 degrees in radians, times the radius squared. Now, how do you convert degrees into radians? Well, 70 degrees converted into radians is multiplied by pi over 180 degrees. So 70 degrees in radians is going to be 70 pi over 180, which reduces down to 7 pi 18ths. So 7/18 pi radians would be the measure of this 70 degree angle in radians, this central angle. So this central angle has a measure of 7 pi 18ths radians. So the measure of the sector AOC is going to be 1/2 times the measure of the central angle in radians, which is 7 pi 18ths, times the radius of the circle squared, which is to say times 9 centimeters squared. So the area of that sector AOC is going to be approximately, when you get on your calculator and calculate this, it's going to be 1/2 times 7 times pi divided by 18 times 9 squared times 81. And I'm getting like about 49.48 square units. So that's the area of the sector AOC. Finally, to find the area of this shaded sector here, this shaded region, that would be equal to the area of the sector AOC minus the area of the triangle. So we're going to take the area of the entire sector, subtract off the area of the triangle, and that will leave us with this shaded region here. So therefore, the area of the shaded region is going to be the area of the entire sector, AOC, minus the area of the triangle. So therefore, it's going to be 49.48 square units minus 4.23 square units, which gives us approximately the area of the shaded region as being 49.48 minus 4.23, which would be about 45.25. So that's what I'm getting here. Base. Let's double check this here. Okay. 1/2 base times height. Just checking this thing out here. 18 cosine 1/2 base times height. Okay, so therefore the area of that shaded sector looks like it would be 49.48 minus 4.23. And let me make sure I was in degree mode. I was. So I'm just going to check the area of the triangle one more time. So it's 0.5 times 18 times cosine of 55 times the sine of 55. And I'm getting like 4.23. Yeah, so therefore, I'm getting an area for the shaded region as being about 45.25. So about 45.25 square units would be the approximate area of the shaded sector there. And so that's what I'm coming out with that problem there.